continuing on with section 3 of chapter 2, we're going to delve into the quotient rule today. And if you wanted to know more about product rule, missed that, there's a video on it as well. So let's go into quotient rule. Now that you've been exposed to the product rule, you probably are a little bit more comfortable with this notion of this kind of recipe on how to take a derivative. And it maybe isn't quite as daunting as it was when we first looked at the product rule. So if I have two things divided, which is what quotient infers, then here's the pattern. Let's say u is my numerator and v is my denominator. The pattern goes the derivative of u multiplied by v. Subtraction, notice subtraction, in product rule it was addition. And then I take the derivative of the bottom, v, multiplied by the top, u. So there's the pattern. It's the derivative of the top times the bottom minus derivative of the bottom times the top. All over the bottom squared. Now it's not the derivative of the bottom squared, it's just the bottom term squared. So there's the pattern for it. You can see here's the theorem from our textbook. They worked in F and G's, so the same rule lays out though. Another thing that I've heard people use is this notion of high and low. So high being my numerator, low being the denominator. And you could say to yourself, it is low d high, meaning derivative of the high. So low d high minus high d low, where we're taking the d stands for derivative of the low. So low d high minus high d low over the square of what's below. And we do low squared. So if that's something that you like to memorize, you could do that, definitely. Low d high minus high d low over the square of what's below. Okay, so here we go. We got g. Not too bad of looking function. It definitely has a fraction to it, so it is the quotient of two items here. I'm going to let this be u and this be v and go into the quotient rule. Now I'm not really a low d high, high d low type of person. I really do derivative of the top times the bottom minus derivative of the bottom times the top. So you're going to probably hear me say that once in a while because that's just how I've always trained myself. So the pattern goes derivative of u. Here is my u, so I'm going to take its derivative. That'll give us 7x to the 6th. Multiplied by v, and v is 3x minus 2. Subtraction sign is next, so subtract. And now you see the u, which is your top, so we could just write down x to the 7th, multiplied by the bottom derivative. So now I got to take the derivative of v, which will simply be 3, won't it? All divided by v squared. V being my denominator, the 3x minus 2 gets squared. And that's what we're left with. The next step, we basically are done. Let's just clean up our work. So I am going to distribute the 7x to the 6th through the parenthesis and get 21x to the 7th minus 14x to the 6th minus 3x to the 7th divided by, I'm not going to expand this out. It would not really be very helpful, so I'll just leave it as 3x minus 2, quantity squared, and you may do the same. Simplifying on top, we can put our x squared terms together, so 21 minus 3 would give me 18x to the 7th minus 14x to the 6th divided by 3x minus 2 quantity squared. If I wanted to, I could GCF out an x to the 6th as well as 18 and 4 have a 2 in common, and that would leave me a 9x minus 7 divided by our 3x minus 2 quantity squared. You know, it is a good idea to do GCF, and then I can get things in a completely factored form. Just always take that extra moment to toss back through and make sure it does equate to what you had started with, and it looks like we're good. Next problem, letter H. Definitely a quotient rule, and I can't change it really into anything else at this point that I could work with. So we're just going to have to start out with that. I'm going to let this be U and this be V, and go into the pattern. So G prime of T. It is the derivative of U times V. So derivative of the top will be 2T times V, 2T minus 7, that bottom, minus derivative of the bottom times the top. So it's minus derivative of the bottom, which is V prime, U. Derivative of the bottom is a 2 multiplied by the top, T squared plus 2, all over bottom squared. Go into some cleaning up. The hard work really is done. Now we're just going to do some distributive steps. Take and send that through. So 2 times 2 is 4t squared minus 14t. Now let's send our 2 through. I'm going to make this a plus minus, so it's a negative 2. So I capture that negative at the same time of negative 2t squared minus 4 divided by the quantity 2t minus 7 squared. Bringing like terms together on the top, I'd have a 2t squared minus 14t minus 4 divided by a 2t minus 7 quantity squared. Oh boy, on top, they have a 2 in common. Let's pull the 2. So I get 2 pulled, I get t squared minus t minus 2 over 2t minus 7. I do believe this will be factorable on top, so I'd have 2t minus 2, t plus 1 for the factoring, divided by 2t minus 7, quantity squared. Did you catch the factoring? You know, when we looked at this trinomial, it does factor into a minus 2 and a plus 1, so that was good. On to letter I. We just have a couple more to do, and then you're going to be able to do homework. So once again, it's U prime times V minus V prime times U for our quotient rule. My U I will assign to the numerator. It now has 3 terms, but the process is going to be the same. Y prime equals the derivative of U, derivative of the top, will be 3x squared plus 3 multiplied by V, which is x squared minus 1. What I just did was U prime times V. And the next thing we need to do is V prime times U. So here we go. Derivative of the V, which comes from the bottom, will be minus the 2x, and then the U is the top portion as is. So that's a 3x cubed plus 3x plus 2. Writing the denominator is easy. It is simply V squared. So it's going to be an x squared minus 1 quantity squared. Okay? It looks like a lot of fun. We got an algebra step ahead of us here where we have to do some foiling, of course. So y prime, this is what becomes the pain when you're working with product and quotient rule, is there is a fair amount of algebra skills that we must do. 3x to the 4th minus 3x squared covers the first term distributing. And then let's distribute the second term through. That's going to pick us up a plus 3x squared minus 3. Once again, I'm going to go plus negative so that my negative gets pushed through. And it's going to be 2x, negative 2x raised to the 4th as it multiplies, minus a 6x squared. That was from there. And then the negative 2x times positive 2 will make negative 4x, divided by our x squared minus 1 quantity squared. collect your like terms, simplify this out, we would have x to the fourth minus, whoops, those are gone, aren't they? So minus 6, I almost did minus 9. Minus 6x squared. So we get the fourths done, and the squarings are done. There are no cubes. I do have a minus 4x and a minus 3 divided by an x squared minus 1 quantity squared. You could try grouping method to see if you could factor that numerator, but from what I'm seeing, I do not believe that's going to factor, so we're just going to leave our answer right like that. On to J. Now, it says complete this, complete the table. Let's just complete the problem without using the quotient rule. How would you do that? From what I see, I got a 7 numerator and a 3x cubed denominator. But would it be okay if I wrote this as 7 times 3x raised to the third to the negative 1? I could do that, couldn't I? You know what? Even better, because I'm kind of wondering, well, how would I take the derivative? What if I isolated this and made it y equals 7/3 and then only brought the x cubed up as x to the negative 3? I like that. That I can handle. This other one was a little more complicated. So this looks good. I think we can simply get by with the power rule and not have to use the quotient rule like it appeared in the very beginning. Nothing wrong with doing quotient rule. You certainly could. We would get the same answer. Just showing you how sometimes you can reorganize and come in with maybe an easier rule. So let's go through our power rule. Remembering that we bring down the negative 3 will come down. So I'm going to have 7/3 times the negative 3 power coming down. X raised to the negative 3 subtract 1 for power rule. What does that leave us? Well, the 3's will cancel and make 1. They divide, really, don't they? And I'll get negative 7. Just don't forget that's still there. X to the negative 4, which that would be rewritten as negative 7 over x to the fourth if I could only use positive exponents in my answer. Excellent. On to the very last problem, I believe. It says, find an equation of the tangent line to the graph of f at the given point. Well, I see our given point. It's 2, 2. We want to write the equation of the tangent line. And in order to do that, I need two things. I need the slope at x equals 2. And then I need my point, which we luckily have. To get the slope, well, we're going to do the derivative, f prime of x, right? And from the looks of it, we have a quotient rule. So derivative of the top times the bottom minus derivative of the bottom times the top divided by the bottom squared. If I did that too fast for you, let's walk through it again. I'll explain. This is my u, this is my v. I did u prime times v. So the derivative of my top, which is u, became 1. The bottom, which is v, is x minus 1. I just write it down. In the quotient rule, we have the negative, and then it's v prime u. So the derivative of the bottom is 1, multiply that by the top, which is x. And then, of course, it's over the bottom, make that look like a v, the bottom squared, which we got there. You know, the more practice you get with these, the faster you do become. And so I would encourage you to work through the homework problems. Spend some time with it because this process does get easier. And it doesn't become quite so regimented about following these rules. Pretty soon you just absorb the rule, and you can just say derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. Or you could go low d high minus high d low, divide all over bottom squared. Okay, x minus x goes away. I think this is going to squeeze down real nice, isn't it? There's our answer. The derivative is equal to -1 over x minus 1 quantity squared. That takes us to the homework, and the homework page is right here. It is day 2, which actually might be day 3 because we spent an extra day on product rule just doing homework. So looking at page 126, do those 6 or 7 problems, and that should give you some good practice. All right, have a great day. I'll also post a PDF of this page if you want, where you can print it out. But I think, once again, use your own paper, then you have lines, and it stays more organized. Bye-bye.